Hi students, I'm back with another lesson. Today we will be studying lesson 5.1. This is the unit that studies proof, and we'll be working with identities to prove or show different equivalents. During this section, I've shared a sheet with you that has all the identities we'll use for this particular part of study. I encourage you to keep that sheet out with you throughout the notes so that you can reference that as well. Today we're going to be studying part 1, which is the basic trig identities and the Pythagorean identities. And your objective of the day is to understand what an identity is and how you can use it to solve for an unknown value. Let's go ahead and get started. The first thing I want to help you understand is what is an identity. An identity is a mathematical expression or description that is true for any variable. For example, a plus negative a is 0. I can plug in any value for a, and that makes this equation always true. Now, an identity says this is going to work no matter what you plug in. This is different from an equation where there's a limited number of answers that make it true. Let's go ahead and take a look at the 8 trig identities, the 8 most basic trig identities we have. The first set of identities we're going to look at are our reciprocal identities. These should be pretty familiar with you at this point. We know that sine is the reciprocal function or has a reciprocal function cosecant. So cosecant is 1 over sine. That means sine is the same as 1 over cosecant. Cosine and secant are the reciprocal functions, so you see that is an equivalent way of writing those. And tangent and cotangent are reciprocal functions. So again, you can see that we can write those with their reciprocal partners. The next 2 are known as our quotient identities. Again, these should be ones you know as well, but maybe not as familiar with. We've used them when evaluating on the unit circle. And that is tangent of x is equal to sine divided by cosine. And cotangent of x is equal to cosine of x divided by sine of x. These are known as our core or basic trig identities. These are used in almost every proof that we do and are often will show up when we're factoring or expanding as well. Next, I want to introduce you to your Pythagorean identities. Now, there are 3 Pythagorean identities we work with. My goal of this is to show you where they come from so that you know that they have connection to and are grounded to things we know. Down in this, right below this table, I have gone ahead and sketched out a picture of the unit circle. So on this picture, we have the triangle drawn in. Notice that I have labeled the coordinate point, and that coordinate point is cosine comma sine. And in that coordinate point, you'll see that the cosine value is the x coordinate, which makes this whole side cosine of x. And the y coordinate is sine of x. So vertically, we've moved up, whatever the sine coordinate is. And because this is grounded on the unit circle, we know that the hypotenuse of this triangle must be 1. So if we apply the a squared plus b squared equals c squared notion, that is where the first identity on the Pythagorean identity list comes from. I would say this is one of the most used identities that we will reference throughout this unit. Now, you might say, well, Ms. Vernon, great, we see that one, but how on earth do you get these other ones? Well, the other identities are going to come from utilizing this first identity, and we're simply going to manipulate it. For example, if I look at tangent, I would say, well, tangent is sine divided by cosine. So if I want to make this become tangent, I can divide this by cosine. But we know in math that we have to keep everything the same, which means if I divide one term by cosine, I need to divide all terms by cosine. Now, I decided to use cosine squared here because we want it to turn into tangent squared. So a squared term divided by another squared term does convert to its basic identity, which in this case is tangent squared. Cosine divided by cosine is 1, and 1 divided by cosine squared is secant squared. There you have it. We've discovered where the second identity comes from. Let's go ahead and duplicate this, and we'll go ahead and show you where the last one comes from. By now you've probably guessed it though. The last one is going to be produced by dividing everything by sine squared. If I want 1 to show up first, I need to divide by sine squared. If I do that to the first term, I need to do that to all terms following it. Because I've done it to everything, I've maintained the equality property of math, so I'm good to go. I can continue to rewrite it. Cosine divided by sine is cotangent, and because both were squared, it becomes cotangent squared. And 1 divided by sine is cosecant, and again, because it was squared, we write it as cosecant squared. There you have it. That is where our 3 basic Pythagorean identities come from. Now I have 2 examples prepared for you for us to talk through how to use these. Here's our first example that we will talk about today. In this example, we may need to use these identities. So notice I've copied them onto the side, but these are the same identities from the previous page. So in example 1, our question that is being asked is we want to find sine of theta and we want to find cosine of theta. In this problem, they are telling us the fact that tangent is equal to 5 and cosine is greater than 0. Well, you might say, okay, that's great, but I have no clue where to start. Well, because we're going to be using our Pythagorean identities and because we were given tangent of theta equals 5, I'm going to pick one of my Pythagorean identities and I need to pick the one that includes tangent in it. Well, there's only one that includes tangent, so that's the one we're going to start off using for this particular problem. When I use this, I'm going to replace the tangent with what I know tangent is, in this case, 5. So we're using tangent squared of theta plus 1 equals secant squared of theta. Because tangent is 5, I can write this as 5 squared. It wasn't just, this was just tangent, so in order to square it, I need to square that value. Plus 1 equals secant squared of theta. 5 squared is 25, and 25 plus 1 is 26. So now I have 26 equals secant squared of theta. All right, we're getting very close. I don't want it to be squared, and I don't want it to be secant. Well, let's get rid of the squaring first. So I'm going to take the square root of both sides, which gives me plus or minus the square root of 26, which equals just regular secant of theta. At this point, you might say, well, Ms. Vernon, I'm not seeing this. I don't see how we're going to get sine or cosine. Well, remember that secant and cosine are reciprocal partners. So I can rewrite this as cosine, but I also will need to flip this fraction. And so that becomes 1 divided by the square root of 26. Next, I need to determine, well, is the cosine value going to be positive or negative? To determine if it's going to be positive or negative, I need to go back to our starting off part. A couple things we know is we know that tangent is positive because it was equal to positive 5. We also know that tangent is sine divided by cosine. And we know that cosine is positive. And if tangent is positive and cosine is positive, we also then know that sine has to also be positive. So at this point, I'm going to ignore the negative and say, okay, I know that cosine of theta is equal to 1 over the square root of 26. There's a second part to this problem, though. Don't forget, we also wanted to find sine of theta. Well, in order to find sine of theta, I'm going to need to utilize my knowledge of tangent because they also gave us tangent. So looking at this, I would go ahead and say, all right, tangent is equal to sine divided by cosine. And I know that tangent is equal to 5 because that's what they told us at the start. So if I want to get sine by itself, I can multiply both sides by cosine of theta. And in doing so, I have isolated my sine. Now, because I solved for cosine of theta, I can also plug that in. I know cosine of theta is 1 divided by the square root of 26, which means sine of theta is equal to 5 divided by the square root of 26. And in our exploration above about whether it's positive or negative, we know it must be positive because we already checked that at the beginning. I have one more example for us today. Let's move on to that. In example 2, we are also going to use the Pythagorean identities to find, this time, tangent of theta. And they told us that we know that secant of theta is 5 divided by 4. So here, again, I'm just going to highlight, we're using the Pythagorean identities to find tangent. This is what we know. Let's go ahead and determine which of our Pythagorean identities we would want to use. Because they gave us secant, you guessed it, we need to use that middle identity again. So let's go ahead and start to apply it. I am using tangent squared of theta plus 1 equals secant squared of theta. Now, sometimes students get confused with theta. Theta is just like a variable, just like x was. So don't get too confused by that. Next, I'm going to plug in what we know. We know that secant is 5 over 4, but we also know we need to square it. Now, I'm looking for tangent, so I need to solve for that. So I'm going to go ahead and kind of do two things at once. I'm going to subtract the 1 over, and I'm also going to square that 5 over 4. So 5 divided by 4 squared is 25 over 16. Now, fractions are much easier to subtract if we have a common denominator. So by subtracting 1 off, I'm really subtracting 16 sixteenths. Now I can simplify that. 25 minus 16 is 9 over 16. Last but not least, I need to take the square root of both sides. And as we've learned, we can take the square root of the numerator and denominator separately. And tangent of theta is equal to plus or minus 3 over 4. Now, just like we had to explore in the previous problem, we need to look at what we were given. So we were originally given that secant, which is the reciprocal of cosine, was a positive 5/4. So we know that cosine is positive. And because of this, sine of theta is less than 0. We know that the sine value is negative. And tangent is sine divided by cosine, which implies that tangent must be negative. So when I write my final answer, I would say tangent of theta is equal to negative 3/4. I hope this was helpful in helping you understand your Pythagorean identity as well as your basic identity. Remember, we'll continue to use these identities as we move forward in our learning. Check back for more lessons in the future. Talk to you soon.